All right, ladies and gentlemen, let's take a look at graphing two-dimensional inequalities. Our goal is to find solutions of the two-dimensional inequalities and to graph those solutions to a two-dimensional inequality. So one way of doing it is just to select an ordered pair, as we saw earlier, and test that ordered pair. So we plug 5 in for x and 2 in for y. So we have 2 is greater than 5 minus 3. We want to check and see, is that true? So we get the statement 2 is greater than 2. We test whether that statement is true or false, and it is false. And so because it is false, we say not a solution. All right, so we did that previously, but I wanted to include that because we're going to use that when we look at making graphs. We're going to graph a boundary line, so we're going to graph either y equals mx plus b, or x and y intercepts. Those are our two options. We're going to use a dashed line for less than or greater than, kind of an open circle. Use a solid line for less than or equal to or greater than or equal to. All right, so let's do that here. I'm going to test using x and y intercepts. So I'm going to cover up, and I get 4x is less than 4. When we plug 0 in here, we're left with just that. And we divide by 4, and we get x is less than 1. Well, we're just really graphing the point x at 1. So we're going to have 1 on our x-axis. We're going to do the same thing for the y-intercept. Negative 2y plus 4x is less than 4. We're going to do that cover up, so we get negative 2y plus 4 times 0 is less than 4. It basically cancels that term, so we can just divide by negative 2. And we get y is greater than, we flip this, of a negative 2. These are just the points. So we go down to our y-intercept at negative 2. We're going to connect those. It is going to be a dashed line because we are just less than. So we're going to connect those. And it's kind of an up 2 over 1. And it's going to be dashed. Well, if you notice, I went through and made it solid anyways. So I'm going to go through and put dashes with my eraser on there. Works out pretty fancy. Now if we look at here, it says test a point not on the boundary line. And when we were looking through at the examples yesterday, we said that 0, 0 is a good point to test. So let's test 0, 0 the way we did previously. So we're going to plug in 0, 0. Negative 2 times 0 plus 4 times 0 is less than 4. So this is for our test. All right? When we take a look at that, the reason we test 0, 0 is so that this whole side simplifies down to 0. 0 is less than 4 is true, which means this point 0, 0 is true. So that means that entire side of the line is true. So we're going to shade the side of the line that contains 0, 0. Now I do want you to keep in mind, ladies and gentlemen, I'm going to do this over here. Some of you do not like graphing with x and y intercepts. So I want to show you, you could solve for y. So you would subtract 4x, and we get negative 2y is less than 4 minus 4x. Divide by negative 2. We get y is greater than, this is negative 2 plus 2x. So there's the negative 2 for our b value. And this is our m value, so we would go up 2 over 1, up 2 over 1. So we would get the same line for that. And notice, because we reverse the inequality, because we solve for y, this tells me to shade above. So that does help me with my shading there. All right, you guys are going to do it on your own. So get that finished, and we'll check that in class. Let's take a look at our word problem now. You bring $48 to a football game and want to buy hot dogs and sodas for your friends. A hot dog is $3 and soda is $4. Write the inequality with two variables and then graph the inequality, which means we're going to have x and y. All right? So I'm going to call x my hot dogs and y my sodas. It doesn't matter which one you use. All right? So if we take a look at this, hot dogs dogs are $3 each, so that's 3x. Do this in red. Sodas are $4. So that's 4y. And because you brought $48, I have less than or equal to $48 to spend. Well, how am I going to graph this? Obviously, I'm going to use x and y intercepts. And so when I graph this, I have an x-intercept of 16. I'm going to have a y-intercept of 12. Counting by ones isn't going to work here, so I'm going to count by twos. So this is 2, 4, 6, 8, 10, 12, 14, 16. So here's my x-intercept. My y-intercept, I should stick to this red coloring that I have here. My y-intercept was that 12, so I'm going to count by twos here. 2, 4, 6, 8, 10. And then here's 12 for what I need. I can spend all $48. It doesn't say you have to bring change home, so this tells me it's going to be a solid line. All right, and so we can kind of go past there. I need to test a point that's not on the line, so I'm going to test 0, 0. We're going to plug 0, 0 in for that. So I'm going to have 3 times 0 plus 4 times 0. Is that less than or equal to $48? Hopefully you realize 0, 0 is already a solution because you can go there and buy 0 hot dogs and 0 sodas and not go over your $48. But we do get a true statement. 0 is less than or 48. It's true, so that means I'm going to shade over all of this. All right? But in reality, ladies and gentlemen, I can't buy negative sodas, so I don't get to use any of these points here. In reality, I don't get to buy negative hot dogs, so I don't get to buy any of these values, these ordered pairs here. So what happens is actually I have this bounded region here that's within these x and y intercepts. That's where I can find my solutions. All right, we will see you guys in class tomorrow. Have a great day.